Hey there, and welcome. Today, we're going to dive into one of the biggest ideas in all of chemistry, how atoms actually connect with each other. And you know what? It all boils down to something we all learned as kids, sharing. Seriously, think about it. You ever had to share a game controller with a friend? Or maybe you pooled your toys together so you could both play? It's such a simple idea, right? But it's also incredibly powerful. Well, believe it or not, atoms, the tiny little building blocks of literally everything, do the exact same thing. Sharing is how they connect, how they build molecules. It's how they create the entire world around us.
Okay, let's get into it. We can really think of this whole thing as the sharing game. And the first thing you need to know about any game is, why are we even playing? What's the goal here?
Well, the goal is pretty simple. Every atom just wants to feel stable and complete. Kind of like when you finally get that full set of action figures you've been collecting. For an atom, being complete means having a full outer layer, or shell, of electrons. And for a lot of them, sharing is the absolute best way to make that happen. So now that we know why they're sharing, let's get a little more specific. This special kind of atomic teamwork has an official name, and it is the star of our show today. It's called a covalent bond. Let's break that down. It's just a bond where two atoms share electrons. It's not about one atom giving an electron away and another one grabbing it. Nope. This is a real partnership, a true two-way street.
So who gets to play in this sharing game? Well, it's mostly the nonmetal atoms. Think of elements like oxygen, carbon, and hydrogen. They all kind of want more electrons, so instead of fighting over them, it just makes more sense to share and work together, you see? It really is all about teamwork.
But here's where it gets really interesting. Just like in real life, sharing isn't always a one-size-fits-all deal. There are different levels to this. I mean, you might share one controller for a quick game, or maybe you and your friend decide to combine your entire Lego collections to build something absolutely epic. Atoms do the exact same thing. They can share different numbers of electron pairs. And this table here lays it out perfectly. A single bond, that's sharing just one pair of electrons, like in a simple hydrogen molecule. A double bond, now we're sharing two pairs. That's what holds the oxygen we're all breathing right now together. And a triple bond, well, that's the ultimate commitment, sharing a whopping 3 pairs of electrons, like in the nitrogen that makes up most of our atmosphere. Yeah, you can think of the single bond as the most common, fundamental handshake between two atoms. A double bond, though, that's a step up. It's a much more involved partnership, and it pulls the atoms closer together. And the triple bond? Whoa, this is the ultimate team-up. With 6 electrons being shared between them, these atoms are locked in a super tight, incredibly powerful connection. So this brings us to a really, really important point. We've got these 3 different levels of sharing, but what does that actually mean for the bond itself? What's the consequence of sharing more stuff? So let me ask you, just take a guess. If a single bond is like sharing one toy and a triple bond is like sharing 3, which connection do you think would be the hardest to pull apart? You probably guessed it. And the answer is just so beautifully simple. The more electrons the atoms share, the stronger their connection gets. Those shared electrons act like a super powerful glue holding the atoms tight. And check this out. This chart illustrates that point perfectly. See how the bar for the single bond is the lowest? The double bond is way stronger. And then look at the triple bond. It's the strongest by a long shot. More sharing equals way more strength. So if there's one thing you remember, make it this simple but powerful rule. Triple bonds are stronger than double bonds, and double bonds are stronger than single bonds. It's a clear hierarchy. The more you share, the stronger you are together. And this has huge real-world consequences. Think about the nitrogen gas that makes up most of the air you're breathing. It's held together by a triple bond. To break that molecule apart takes a massive amount of energy, and that's exactly why it's so stable and doesn't really react with much. So let's wrap this all up with the key takeaways. Number 1, covalent bonding is all about atoms sharing electrons to get stable. Number 2, this sharing can happen in 3 different ways: single, double, or triple. And number 3, the big one, the more electrons you share, the stronger that bond is going to be. Simple as that. But that leaves us with one final, very interesting thought. We've seen how powerful teamwork and sharing can be. So what happens in the atomic world when one atom is a little bit greedier? What happens when, instead of sharing, it just
takes the electrons for itself. Well, that's a whole different kind of bond and a story for another time. Thanks for joining me.